Thank you, Smita ma'am, for nice information about how to conduct the and what functions should be used. Okay.
Thank you,
Next
ma'am.
is the should we go for the 4 and 5?
Yes, yes, madam. Dolara madam is still doing
Yeah,
that.
it's
So I have
okay,
told
ma'am.
her to call me.
We can. It's an installation and study assignment that can be
Yeah, yeah.
discussed double
No, no,
also.
she is
So
trying. Some problem is there. So when she is ready, she will call me. Till
yeah,
now, we will continue with the next assignments.
yeah. So Vaishali Ingle ma'am, are you there? Yeah,
Yes.
she has uploaded. Okay.
Okay.
Okay, you can
Good.
start, ma'am.
Okay. Good afternoon, everyone. Myself, Professor Vaishali Ingre. I'm assistant professor in Army Institute of Technology, Diki, Pune. So, first of all, I want to thank all the BOS member as well as Dr. Dipti Patil ma'am to giving me the opportunity and being a part of the syllabus setting and lab setting team. Okay, so in this FOP, I'm going to focus on the assignment number 4 and assignment number 5. So the first of all, we will see assignment number 4, anomaly detection using autoencoder. So the problem statement given in the syllabus is use autoencoder to implement anomaly detection, build the model by using import the required library, upload, access the data set, encoder converts it into the latent representation, decoder networks convert it back to the again original one and compile and access the performance of the model. So before going to the actual assignment, I just want to brush up the thing. So basically, what is autoencoder? So students should able to understand what is generative unsupervised deep learning model. So this is the expected question to understand to check the understanding of the students. So and basically it is used for reconstructing the high dimensional input using neural network with the narrow bottleneck layer in the middle, which contains the latent representation of the data. So over here, okay. So over here in this autoencoder, this is the architecture diagram of autoencoder. So we do have over here, we do have the input. This is the reconstructed output. So what we want the identical, if my input is X, so we want the identical representation of the input X dash. So what it do, the encoder takes the input. This encoder convert it to the low dimensional, compressed low dimensional form. And this is the bottleneck. This is nothing but the latent representation. Decoder take this input and again by performing the operation, it will be going to generate the original one. So as we discussed, there are the basically two stages of the autoencoder. One is the encoder and another one is the decoder. So encoder take the high dimensional, decoder will going to convert it into the low dimensional. And in between we require the bottleneck that is going to convert it to the latent representation. So as again, this is the expected question during the practical examination. What are the different applications of autoencoder? So students should able to answer this. So basically autoencoder, I listed few. So autoencoder is used for dimensional reductionality, recommendation engine, anomaly detection. So we are focusing on this. Denoising images, image recreation, and image generation. So basically as the subject is to the BE students, and most of the students can use the autoencoder for on the images also. So there might be the side confusion between the students that what will be my output, whether I will get the basically they are working with some image recognition or denoising the images. So what will be in my output? So it is some kind of prediction, it will we will going to see it, some kind of prediction it will be going to do, and that will be if there is the difference between the actual and the predicted one, so that will be going to detect it as an anomaly, so by using some threshold values. So over here these are the following steps of the auto encoding. So first of all, we do have to pass the training data set as a normal data set. the bottleneck layer will going to convert it to the latent representation. Then we do require decoder. So decoder will take the input from the bottleneck layer and reconstruct the original one. And wherever the fraud transaction is there, so there will be the trouble in the auto encoder to reconstruct the original data. So here the reconstruction error will be high, and then we will say that the anomaly exists in a particular data. So in the assignment, what I I basically use the credit card fraud detection dataset, and this is the link for downloading the dataset. It present in the Kaggle. Right. Similarly, what I want, if students are ready to work on the images, that will also do, but my suggestion will be just go for the CSV file, the text data, go with this text data. So the autoencoder that we are going to create, it will be the architecture of diagram will be this one. So this is input having some layer, so 14 layers, then 7 layers, then this will be the bottleneck that will be going to consider the 4 features, and then vice versa, so that the we can able to construct the actual input. Okay, so this is my Python notebook. So the first step was what explain about what are the different packages that we do require. So these are the listing of I had install those packages, and these are the listing of packages that we do require. So basically we work with the TensorFlow, Keras, and Torch. Similarly, we do have to import the confusion matrix to access the performance of the model, and we do have to test the divide the your data set into training and testing. So according to the data set, we do have 2 labels, normal and fraud, and this is in this code we just import the file and just describe what are different columns or what are different features are there in the data set. So as we are observing over here, there are total 31 features. So out of this, one is the output feature and 30 is the input feature. So the next thing that we required, we do have to do pre-processing of the data. So identifying how many unique values are there. So according to that, we can label it. Similarly, how many null values and all. After the thing that I want to tell you, autoencoder is also the beauty of the autoencoder is that it works with the imbalanced data set also. So because of this, in this example, I had taken the example of imbalanced data set. So as we can see, we have the more number of samples, and that is the correct, and the fraud having, we have just have few number of samples over here. So we said we have 2,84,315 as a normal transaction, and 492 as a fraud transactions over here. Now, at this stage, we do have to split the data set, and we are just checking by using histogram what are the normal and the fraud transactions are available over here. So these are the steps that is used for as it is work with the time. Time is the one of the feature over here. So, and that is we require the normalization over here. So these are the steps that is going to do the normalization task. Then the next one is we need to divide. So training data set with the actual normal data. So so number of samples in the training data set having normal value, number of samples in the training data set with the fraud values, and same is related to the test one. So over here it is mentioned over here. So now this is the important one. As you have to, means you have to tell the students, being a teacher, that the student should select the data set so wisely that the maximum number of epochs that you require should not be go beyond 100. Otherwise, the whole 3 hours they require for training the data set only. So just wisely select the data set. Otherwise, whatever the accepted output, because we are early stop, we might be going to use early stop function over there. So whatever the expected output, we will not get if the data set is not selected wisely. So over here, I had tried a lot of data set over there, and then finally I found that credit card fraud detection data set is appropriate, that it will be get run. We will get the appropriate output within 3 hours. So the number of epochs, batch size, and encoding, hidden layer, learning rate that setting is get done. Now this is the input layer. So we said in the input layer, total number of dimensions that we have, total 31 features was there. So 30 was the input one. Then now we said encoder is going to what latent representation produce, and same latent representation will be the input to the decoder. Is anyone have any issues? Okay. So decoder will take the same input, and according to that, over here this is going to create the model, the autoencoder. So we had summarized this, and according to this you can see the shapes over here. The next thing we do have to, this is the early stopping function. Then we need to compile the autoencoder, and then we will going to feed it. So the number of epochs that will be over here, we can see the training loss that we had plotted over here. Then the prediction, now this is the actual prediction that it will be going to do. We will take the mean square error, and according to that, if it is go beyond the threshold value, so we will say the anomaly is get detected. So as you can see over here, this is totally the imbalanced data set. So over here, these are the anomaly that is get detected by the autoencoder. So this is all about the first assignment. So as we said, the autoencoder conclusion of this autoencoder is basically used for, we can be used for the anomaly detection, and it works good with the unbalanced data set also. So this is the references that we had used to implement this assignment. Now the next assignment is assignment number 5, and that is continuous bag of words. So comparatively, assignment number 4, this assignment is very simple, and students, most of the students will going to like this assignment. So according to the problem statement that is given in the syllabus is implement the continuous bag of words model, and the stages that we can perform is data preparation, generating the training data, training a model, and the output. Now over here, if you can see the variations of this data set, so students theoretically should know what is the single word model and the multi-word model. So they should able to theoretically differentiate between these two models. But mostly we are focusing on the single word model. So the prediction from this model will be a single word instead of predicting the multi-word. So again, the same flow I'm going to maintain over here. So before going to the actual assignment, we will see what is the continuous bag of words. So this is this model tries to understand the context of the words that and takes the input. Then it will be going to predict the word, and that is accurate, conceptually accurate to that particular sentence. So over here, I like natural, so we need to predict this particular word, and over here it will be going to perform. So over here, the example is it is a pleasant day. So the word now we are giving the input it is a and day. So we are expecting the model should predict it is the pleasant word should be get predicted. So over here we will basically again the student should aware of which kind of encoding scheme that you're going to use. So over here I prefer the one hot encoding scheme because our paragraph is very small, and we expect that students should perform this assignment within 3 hours. And similarly, we can measure the error with again one hot coding target word. So now depending upon our output, we will going to print the accuracy of this model. So this is the model architecture. So these are the number of words. This we will try the various combinations of words. So that will becomes the bag. Then the neural network will be get trained accordingly, and then it will be going to predict the words. So this is the next assignment. Okay, over here, we do require these packages. So, and as we do work on a simple data set, so actually you can store the input in the text file and we can import that text file, or you can directly store the string directly over here in the Jupyter notebook also. So this is going to pre-processing that we do require. So this is going to remove, this stage is going to clean the data. So remove some special symbols, comma, punctuation marks, and so on. So, and it is going to convert it to all the lower cases. So this process, this stage is the cleaning process. And then vocabulary, it will be going to create by converting the splitting the one string into the multiple words. The context size that we had used this thing. So over here, this is the implementation stage. Then data bags are created over here. So in this output, you can see, we can see the data bag. So over here, what we are to study. So the word was in between about. So this will be my target word. So according to that, the data bags are created. Then this is the embedding scheme that over there we have to specify the embedded dimension and vocabulary dimension. So this is the linear model, log, max, and entropy scheme that you had used, the soft max. So now, as we said, the forward function. So basically over here, the forward function will going to what it will be going to train the model by using the data bags, and the backward function that we required, whatever the error during the training, whatever the error that we require, so according to that weight adjustment should be get done. So this is over here, this is the forward function and this is the backward function. Similarly, we do think about the optimization function. This is the learning rate that we had specified is 0.03. So actual training is happening over here. The number of epochs, again, over here we had used as 80. So this is the simple, you can do it fastly. Then this is the loss that we had shown over here. And this is the predict function. So as we said, we are to study. So the target was word was the about. So we are passing in predict, and it is accurately predicting the word about. So the accuracy we will going to measure, and the accuracy that we are getting it as 100%. The same thing, other statement that we had passed over here is now instead of 3, we are passing the 4-1 process, manipulate, think, study. So the expected output was the abstract. So that you can verify from this particular string. Okay. So as I already told you, the stages are data preparation, generating the training data set, training the model by the forward pass and backward propagation for adjusting the weight, and the output will be get the similar word. So this is the reference that you can use for accessing this. So this is all about the assignment number 4 and 5. So thank you.
Thank you, Vaishali ma'am, for your very nice explanation and sharing your Jupyter notebook, and just showing how the different steps and what are the commands associated with that steps, okay, related to the assignment. Uh, we first of all will finish up all 6 assignments, and then we'll be open for the discussion. I know the participants might be having many questions related to the assignments and all these things. So first of all, let us complete the discussion, and then we'll be getting, if we are getting few minutes time, we will get it. Then we'll open for the discussion, and then your whatever uh, thoughts you want to share with the other participants, you can pick up the questions and ask. So, sixth assignment will be explained by the Yogita ma'am. Yogita ma'am, are you there? Am I audible? Am I audible?
Yes, yes.
Yogita ma'am, are you there?